Here are your objectives for 4.2. Change from logarithmic to exponential form. Change from exponential to logarithmic form. Evaluate logarithms. Use basic logarithmic properties. Graph logarithmic functions. Find a domain of a logarithmic function. Use common logs and use natural logs. Okay? So, first things first. Can you go back and forth from logarithmic to exponential form? That's the main thing at the beginning of this section. So a logarithmic form will look something like this. Y equals log base b of x. And I need you to be able to go to exponential form from here. The base of the logarithm is the base of the exponent. The answer of the logarithm is the exponent. And then the argument of the logarithm is what it equals over here. Okay? So as long as you can go from here to here, and as long as you can go from here to here, you're going to be fine. Okay? So if I say 2 equals log base 5 of x, can you write it in exponential form? Well, the base of the log is the base of the exponent. The answer to the logarithm is the exponent, and then the argument is the answer. Now, this is something, we're not there yet, but this is something we could easily solve. If they gave it to us in this form, it's not as easy to solve, but if I write it in exponential form, I know the answer automatically is 25, because I know what 5 squared is. I can't do a lot of log stuff in my head, but I can do exponent stuff in my head. Okay? So that's the importance of being able to go back and forth from these. Sometimes they're going to give them to you in this form, and you need them in this form because you can see a pattern or one of those little easy steps that we can do. And sometimes if it's in this form, in logarithmic form, we want it in exponential because it's something like this where I can see the answer right away. Okay? What about if it's m to the 7th equals 2x? Is that something we can rewrite into logarithmic form? Hopefully. So the exponent is the answer here. The base is the base of the logarithm, and that equals, so not equals, but the argument is that answer over there. Okay? I saw one time someone say if you want it in logarithmic form and you want it in exponential form, you kind of got to draw an E. I'm not really sure how it's an E, but they drew it as an E, so I'm just going to show you. If you start here, you go here and then here, and I guess I can see that as an E if you draw like a line there. But you start with the base, then you go over here, and then up there. B, Y, X. Okay. Some people need different things. I just want to make sure to show you what I have. Okay? The next thing you have to be able to do is evaluate logarithms. Okay, and in this case, what they mean by evaluate is when you're going back and forth, is it something you can do in your head, like this one we just saw? Okay, so if I say log base 2 of 16 equals x, is that something you can easily figure out if you put it in exponential form? Well, 2 to the x equals 16. Do you know what x equals? You can see that, right? You can see that x equals 4. Or if you think about it for a second, if you can't see it, at least it's something you can think about and figure it out. Okay? Another thing that you can do here, just for the record, I don't know if you remember this shortcut for logarithms. We could actually write it like that. Okay? Because 2 to the 4th is 16, right? Why would I make it 2 to the 4th on purpose? Well, if this base and this base are the same, what's the answer? That exponent, right? Even if I rewrote it in this form, I would have 2 to the x equals 2 to the 4. Well, that's really obvious what x equals now. X has to equal 4, doesn't it? So what I'm trying to show you here is there's actually multiple ways to get to the answer. Okay? And in this particular case, because of our calculators, because of how well, they're not smart. Only the users are smart. But what they're capable of doing, we can just put that straight in the calculator, log base 2 of 16, and hit enter, and it'll tell us 4. Okay, so there's at least 3 ways I just showed you right now to get to this answer. Okay, log base 7 of 1 over 49. Well, I could rewrite that in exponential form, which would be 7 to the x power equals 1 over 49. That's not always easy to see for some people, but if you'll remember, if we write this log base 7 of 7 to the negative 2 power, because 49 is 7 squared, right? But if I put it just in negative exponents, that's 7 to the negative 2 power. Again, I can see that 7 to the x power equals 7 to the negative 2 power, and I can tell that the answer is negative 2. Okay? Log base 25 of 5 equals x. 25 to the x power equals 5. 25 to what power equals 5? Well, 25, what action can you perform on 25 to make it be 5? You could square root it, right? And you remember that exponents, square root for exponents are fractional exponents. Okay? Log base 2 of the 5th root of 2. So 2 to the x power equals 2 to the 1/5 power. Because remember, if we have fractional exponents, the numerator is the power and the denominator is the root. So again, that's pretty obvious what x is going to be now. If 2 to the x equals 2 to the 1/5, you know x has to equal 1/5. Okay? X equals 1/5. There you go. There are some, we talked about a little bit of shortcuts up here, but just a reminder, if we have log base 7 of 7, that's automatically going to equal what? When the base and the argument are the same, it's a 1. Okay? Logically thinking, if we're thinking about it, if we're going through exponential form, 7 to what power equals 7? Well, that's a 1, right? Pretty obvious. So things like log base 5 of 5 is not something we have to think about. Log base 12 of 12 is not something we have to think about. Log base 12 of 1 is also not something we have to think about, because if I write it in exponential form, 12 to what power equals 1? 0. Because I know anything to the 0 power equals 1. So if my argument is 0, it doesn't matter what my base is, does it? It could be log base 5 of 1. I know that's going to equal 0, because the only thing I can raise a base to make it equal 1 is the 0. Okay? Okay so far? All right. Let me show you really quick the inverse property of logarithms. So inverse property of logarithms, it says for b is greater than 0, that has to be true, and b also does not equal 1. So it has to be greater than 0, but not 1. Log base b of b to the x equals x. Also, b to the log base b of x equals x. Well, this one's pretty obvious, right? Why this is true? Because b to whatever power is going to be b to the x, so that whatever power is going to have to equal x. Why is this one true? Remember when we talked about this last year, we said whenever the bases are the same, the answer is the exponent. Doesn't that go true here? Aren't these bases the same? So the answer is just what's left here in the exponent, which is just x. Okay? So if I say log base 7 of 7 to the 8th power, I know that's 8, because when these bases are the same, that's my answer. Okay? Or when I say 3 log base 3 of 2x, I know my answer is 2x, because when my bases are the same, my answer is just what's left. Got it? Transformations, being able to graph logarithmic functions is the next thing on our list of objectives. Okay, graphing logarithms right here. Same kind of rules that we went over in the last section, in section 4.1 about exponents. They also apply here. But let me give you an idea of what I'm talking about. What does the A cause? Okay. It's outside, so it's a vertical change. It's either a stretch or a compression. But remember, another word for compression is shrink. Okay. Also, the other thing about A is it could either be positive or negative as well, right? Positive or negative. That positive doesn't change anything, but a negative causes a reflection. Okay, if it's inside this H, what is that going to cause? Can I change something real quick because I wrote it wrong? Okay, this should be a minus. I need you to fix that. It should be a minus. Okay? Because remember, the H is the direction it tells us to go. So if it says x minus 2, we actually go right 2. Because my H value is 2. Does that make sense? Okay. What kind of changes the K cause here? Excellent. Now if it says plus 2, I actually move up 2 because it's plus K in the formula, so I do exactly what it says. Okay? That's something we did a lot of transformations in Algebra 2, right? So are you okay with that? If not, what do you do? Ask. Yes. Okay. If you'll remember, I told you a minute ago, but exponential functions and logarithmic functions are related how? They're inverses, and when we did exponential functions, we always moved this point, 0, 1. Okay, what point do we move in a logarithmic function? 1, 0. That's the point that's the easiest to move, so we can keep track of where we're going with all the transformations that are involved. Okay, for a parent function, what is the domain for a parent function? Logarithm. Like log base 2 of x. Domain is x is greater than 0. Is it ever going to get to 0? No, never. Okay, so really, remember the other way we can do this is this way, interval notation. Okay, just keep in mind, sometimes it'll ask for interval notation, sometimes it'll ask for inequality notation. I need you to remember the difference. Okay, so if I say to you log base 4 of x minus 5, you need to be able to find a domain from that. Okay, this is moved to the right 5, so how does that affect here? It's going to move to the right 5. So my domain is going to be what? X is greater than 5. Or 0 to 5. Does that make sense? Yes? Except I wrote the wrong. I'm sorry. Thank you. Wouldn't it just be what? 5 to infinity. Please forgive me. Okay. 2, 3, 4, 5. That's not exactly right, but it's close. Thank you. I've been practicing my sound effects. Okay. How are you feeling so far? Okay, so that was graphing logarithms, and that was also finding domain of logarithms. The last two things on our objectives are using common logarithms and using natural logarithms. Do you remember the difference? Okay, so common log is log base 10, or it can actually look like this. Like I don't even write the base because it's the one we use most common, so sometimes we don't even have to write it. Okay, and natural log is log base e, but we will never write it like that because we don't want mathematicians making fun of us. We will say natural log of x. Okay, any questions about that? So all the same rules that just applied for the shortcuts, things I was showing you like these all apply to these as well. So if I say log of 10 to the 4th power, what's the answer? Well, is the base the same as this base? And the answer is 4. Okay? If I say natural log of e to the 6th, what's the answer? What's the base of natural log? E. So the bases are the same, so the answer is 6. Okay? If I say 10 to the log of 5x, well, the base and the base are the same, so answer is just what's left. If I say e to the natural log of 7, the answer is just 7 because the base and the base are the same. Okay? Does that make sense? Any questions?